Alright, in this lesson we're going to solve compound inequalities. Compound inequalities are just like multi-step inequalities, except for you have now two inequality signs. Alright, but you take the same steps to solving any of these inequalities. You know, addition, subtraction, multiplication, division, you do all those same things that you would do to solve an equation or a multi-step inequality you would do to solve a compound inequality. Our goal is to get x by itself. So if I want to get x by itself, the first thing I'm going to do is subtract 5 from each side. So I subtract 5 from the middle, that means I got to subtract 5 from both the inside and the outside. Now remember, these inequality signs, they're like the equal sign. They never change. Alright, they don't go away. So if I start a problem with two inequality signs, I'm going to end the problem with two inequality signs. So I subtract 5 from all three sides. That gives me negative 3 less than x less than 4. And at this point here, I have this problem solved. What this is telling me is my number that I'm looking for is between negative 3 and 4. But it can't equal negative 3, and it can't equal 4. So it's got to be numbers like negative 2, negative 1, 0, 1, 2, 3. Or any decimals in that range. So let's write the corresponding interval. So negative 3 is the smallest number to 4. I can't equal negative 3, so I'm going to put a parentheses. I can't equal 4, so I'll put a parentheses there. So this is my new interval, negative 3 to 4. Now I'm going to draw the number line. I'm going to mark negative 3. I'm going to mark 4. I've got to put two dots now. Negative 3 because I cannot equal, it's going to be an open dot. 4, I can't equal 4, so I'm going to put an open dot there. Then I just, because x has to be in the middle, I just connect the two, saying that these two, or the numbers, have to lie within negative 3 to 4. So this problem is an AND problem. It means that x has to be greater than negative 3 and less than 4. If we go ahead and draw the graph, x means we have vertical lines, all right, and neither of these are equal, so the dashed lines. So vertical line at negative 3, and a vertical line at 4. X has to be in the middle, so that means I have to shade in the middle in between these two lines right there. At this point, I've solved the inequality. I've got the interval, the number line, and the coordinate plane representing all the solutions for this inequality. Now let's look at this other inequality, and let's look at it in a different way. So what I'm going to do is I'm going to actually split this up, all right, to start this problem. Now you can solve this one right here just as you did here, but I'm going to split it up to begin with to show you that this is like an AND problem. So we're going to split it up, and we're going to say 10 is less than or equal to negative 2y plus 4, and negative 2y plus 4 is less than or equal to 24. And we're going to solve these separately. So in this problem here, this would mean 10 less than or equal to negative 2y plus 4 and negative 2y plus 4 less than or equal to 24. Because the variable is in the middle between two inequality signs, that's meaning that this is in an AND problem. So we're going to solve the left side, subtract 4 from each side. We get 6 less than or equal to negative 2y. Now we divide by a negative 2. Remember, when you divide by a negative 2, what happens to the sign, to the inequality? It flips. So it's now greater than or equal to. You got negative 3 here, y here. Now let's solve the other side. We subtract 4 from both sides. That gives you negative 2y less than or equal to 20. And we're going to divide by a negative 2.
Brady Beerbauer, you have a message at the window.
And we're going to divide by a negative 2. And remember to switch the sign when you divide by a negative, so this inequality sign will flip. So y greater than or equal to negative 10. So this is telling you that y has to be less than or equal to negative 3, but it has to be greater than or equal to negative 10. All right? So y has to be less than or equal to negative 3, and y has to be greater than or equal to negative 10, which is telling you it's between negative 3 and negative 10. So let's go ahead and draw this. Write the interval notation. So negative 10 is the smallest number. Negative 10 to negative 3. Both could be equal. So we got a bracket here and a bracket here. We're going to draw the number line. Negative 10 here. Negative 3 here. We got a closed dot on both because they could be equal. And we're going to draw a line between each. All right, these are where all the solutions lie. We have a y variable, so we're going to draw the coordinate plane. Because I got a y variable, that means I got horizontal lines, and because they could be equal, I've got bold lines. So a horizontal line at negative 3. And then a horizontal line at negative 10. It's got to be in between, so I'm going to shade in between, and that's where all my solutions lie. Now let's look at the or sign. So we solved compound inequalities with the and sign. Now we're going to solve compound inequalities with the or sign. These ones are a little bit easier, I think. They're already split up for you, so you just solve the left side, figure out what x has to be less than or greater than 2, and then solve the right side. And then at the very end, then you'll just write the notation, graph it on a number line, and graph it on a coordinate plane. So we'll solve this one here. We're going to subtract 3 from both sides. It's 2x less than 6. Divide by 2. So x is less than 6. Or add 6 to both sides. So 3x greater than 18. Divide by 3. So x has to be greater than 6. Now you'll see why this is an or problem, because x has to be less than 6 or x has to be greater than 6. So it could either be numbers that are less than 6 or numbers that are greater than 6. So really the only number it can't be is 6. It can be any other number and you would satisfy this inequality. So let's go ahead and draw the interval notation. So really for this there's like two interval notations. For this one here, x is less than 6. This is negative infinity to 6, both with parentheses. And then this one would be 6 to infinity with two parentheses. So in this, whenever you're doing an or, you have to kind of represent the intervals separate, and then you'll see that the only number it couldn't be is 6. So it can be any number but 6. Now we'll draw the number line. What's nice about this is we know the only number that it couldn't be is 6. We're going to draw a circle. And actually we got to point the arrow both ways, because x has to be less than 6, which would be this way, and x has to be greater than 6, which would be this way. So it could be either one. So we point it either direction. And then finally we're going to draw a graph. When we draw the graph, we got an x variable, so that means at 6 we have a dashed line, which is vertical. And then because I can shade either side, I can shade this direction and shade this direction. So that's kind of cool that the only line that doesn't work is x equals 6. Anything else works. All these other things are solutions. Now let's look at the other or problem here. We're doing the same type of thing. We're going to solve the left side first. So we got 4y less than or equal to negative 4. Or, and let's add 3 to both sides. So that's 5c greater than 20. Now we're going to divide by 4. So y is less than or equal to negative 4. Or y is less than or equal to negative 1. Or, divide by 5. C is greater than 4. So now we can go ahead and graph this, or write the corresponding notation. This means y is less than -1, or c is greater than 4. So the two intervals that we'll have here, we'll have -infinity to -1, could be equal, so we got a bracket there, or we'll go c greater than 4, so it's 4 to infinity with two parentheses. Now we're going to draw the number line. We've got -1 here, and we've got 4 here. We got a closed dot on -1, pointed to the left. We got an open dot on 4, pointed to the right. And then finally we're going to graph it. -1 is going to have a bold line. Because we're using the variable y, we have a horizontal line, so -1, bold line here. 4 will have a dashed line. For the -1, it says to shade below. Y is less than -1, less than or equal to -1. And for this one, c is greater than 4. I'm going to shade above. By the way, this variable right here, I forgot to switch it. This should actually be a y in the problem. So instead of it being a c, just think of it as a y. Don't forget to do the U-try problems.